Hello everyone, welcome. Today we're going to solve a problem from a weekly contest 437, and the problem says select k disjoint special substrings. The problem description goes as follows: and given string s of length n and an integer k, determine whether it is possible to select k disjoint special substrings. And special substring is a substring where any character present inside the substring should not appear outside it in the string, and the substring is not the whole string. And note that the k substring must be disjoint, they cannot overlap, and our target is to return true if it is possible to select k such disjoint special substrings, otherwise we return false. So let's see an example, and we're given this string and k is equal to 2. And if we have to select special substrings, you can select a substring containing C and D and a substring containing E and F, because C only present in this substring as well as D, and E and F also present in this substring only. And that will result in two special substrings. Since we have two special substring, we can say that we can make K special substring in this case. But we can also select only C and D independently, and that will result in 4 substring, which is special. And since we can make 4, it's obvious we can make 2. So we can return true in this case as well. And if we have to see this in brute force way, we can generate all the substring, and from those substrings we can store the interval of special substrings. Then we can identify the non-overlapping intervals from the stored intervals, right? So what I mean by that is I'm going to demonstrate a simpler example, and you will see the whole image. And if we started at C, we can make a substring only containing C because C present only in the substring. And we can also select another substring which is C and D because both of them present in the substring only. So it's going to be the same for all of them. And if you have to see for A, since we have to select up until to 8, and we also have B in the middle, and that will expand our interval up to 9 because we cannot select substring which the character in the substring is outside of that interval. So that's why we selected 0 up to 9. We cannot say only 0 up to 8. That's because of B. Actually, I'm going to demonstrate that later in depth. But we can generate the intervals in linear time instead of generating all the substring, and we can do that with sliding window technique. And the thing that we are going to do, we are going to select an A, the first occurrence of A, and starting from here, which is special substring, we can select that's what we are trying to find. And it's obvious, right? We have to, at most, we have to include all the A's inside the interval. And that's going to include up to 8 because the last occurrence of A is at position 8. And we can say this is the special substring we have for now. But the problem is the character in between could expand our intervals. So we are going to check for all of the character in between our interval. And we check B. And when we see B, the first occurrence of B is here, and the last occurrence of B is at position 9. And this is telling us that we have to expand our window because we cannot select this as a special substring because B would be outside the substring. So in that case, we're going to expand our window and we're going to start checking for all characters. And we say C. C is only present in position 2, so we skip it. D, we have only one D. And when we check for B, since it is going to be at position 9, we're not going to do anything different. And for A, we're going to check the last occurrence of A, and that is 8. And since our interval is greater than the last point of our interval is greater than the last position of A, we're not going to do anything as well. And for E, we have only one E. For F, it's going to be the same. And one thing that you have to note is, let's say, let me just change this A into C for demonstration purpose. And let's say our interval is this, starting at 2 and ending at 8. And if a character's starting position is outside the interval, and we are checking for all of them, and we are checking for B for now, and we see that the first occurrence of B is actually at 1. And when such kind of case happens, we consider the interval to be invalid because we already counted or stored the interval that starts at B. That's how sliding window works. We cannot go back. We just move forward. And by doing this, we collect all the intervals. And after generating the intervals of special substrings, we can now count the non-overlapping intervals. And how do we do that? We are going to sort the intervals by their ending time. And we're going to check if one of them overlap the other. And if I have to demonstrate double example, let's say this is the interval we have, and we have 5 intervals. Since we are going to sort them with their ending point, so this one is going to visit it first, and we check if the first or starting point of this interval is greater than the previous ending point. Since we don't have any intervals for now, we just say this is the first interval we have, and the last ending point would be the ending point of this the last visited interval. And when we get to this point, we will check if the starting point of this interval is actually less than or equal to the interval that we had before. And in this case, it is greater, so this means that we can have 2 intervals that are not overlapping. And we move on. Then this one is going to be visited thirdly because the last or the ending point of this interval is after these 2 intervals. And the starting point is actually less than the ending point of the last visited interval, right? This tells us that this interval overlaps with last interval, so we cannot count it. And we move on. And yeah, this is how the thing is going to be implemented. So the code is actually quite easy for this one, for this part. So let me just jump into coding part. All right. So first we need the first occurrence of the characters. So we say -1 for all of them in the beginning. And we will do the same thing for the last occurrence actually. And we're going to iterate over a string, and we're going to capture the first and last occurrence of a character. And we say index is going to be order of character at I minus order of A. This is gives 0 up to 25 indexed characters. And if the first occurrence of that index is not modified yet, so we would modify it to be this one. Index is going to be I, and the last occurrence is actually current index for every character we face. This would give us the first occurrence and last occurrence of each of them. And we also need intervals where we are going to put our intervals, and we also need an answer. And after that, we are going to iterate over the string, and we will say again index is going to be the order of string at I minus order of, I will give it the position again. And if the first occurrence of this character is not equal to the current position, so we don't do anything because we already counted for that. And if not, we say the start, and end is going to be, start is going to be an I, and the end is going to be last occurrence of that character. And our j is going to be start. This is to iterate between the intervals, and while our j is equal to or less than the end, we would check things, and also we need some kind of flag. So whenever we found a character that is the starting position of that character is outside the interval, so the interval is invalid. And again, I'm going to say new index is going to be this order, and this should be j. And if first occurrence of new index is less than the start, we would make our flag to be false, and we're going to break the while loop. And if not, we would say our end is going to be maximum of the end, and the last occurrence of the new index. So this is actually expanding the intervals we have, and we don't have to forget to increment our j. And once we are done with that, if our flag is false, we are going to continue. And also, if the start is equal to 0 and the end is equal to length of s minus 1, we are going to continue as well. This is if the substring is the whole string. And to our intervals, we're going to add the start and ending point. And once we say that, we're going to sort our intervals based on the last element, so x of 1. And once we're done with that, we're going to say previous is going to be minus 1, and for range of intervals, and if the interval point of the starting point of the interval is actually greater than the previous ending point, we can increase our answer. And we also need to modify our previous to be intervals at 1, and we don't have to forget to make intervals at ice position. And once we are done with that, we're going to return answer is greater than equal to k. And this should work. Let me check it. Yeah. So as you can see, it is accepted. Thank you for watching.